So this is 8.2, page 4, more word problems with rates. First question is example 4. Amelia walks at 6 kilometers per hour and burns 454 calories in 2 hours. We look at Bruce. He walks at 4 kilometers per hour and burns 62 calories in 30 minutes. We are then asked, if Bruce walks for 2 hours, how long does Amelia need to walk to burn the same amount of calories as Bruce? Assume both people walk at their respective rates, so it means they're consistently walking at the same speed. So let's look at Bruce, the amount of calories that Bruce has burnt. We know that he is walking for 2 hours, and we write this as a fraction over top of 1, so it's visually easier to see the units that are canceling out. We know that his rate is 62 calories in minutes, so what we got to do is change hours to minutes. So our conversion factor, 60 minutes over top of 1 hour. We'll turn hours into minutes. We then know that for every minute he burns 62 calories. So as we see the units that cancel out, we see hours cancel out, top and bottom, minutes cancel out, top and bottom, and we see that calories is the only unit that's left over. We do the math, we see that we have 248 calories. So, but we are asked, what is the amount of time that Amelia needs to walk to burn the same amount of calories? So we will start with 248 calories, because that's what's equal. We know that her rate is 450 calories in 2 hours. So we write this upside down because we want calories to cancel out. And we see that this is 1.09 hours, and we see that the calories cancel out. We could have also been asked maybe, what if you were asked another step, how long is this in minutes? We could have simply taken our 1.09 hours, another conversion factor, minutes over hours, and we get 65.55 minutes. And we see our hours canceling out. Example 5. Kelly can paint a room in 4 hours, while Tony needs 6 hours. The question here is, how long is it to paint the room if they work together? So let's look at what each one of them does. They can, if we talk about rooms per hour that Kelly can paint, it's 1 room for every 4 hours. Tony is 1 room for every 6 hours. So what do they do together? Well, what we do is we simply add those values together, those rates. 1/4 plus 1/6. Remember rules of adding fractions, we have to have a common denominator. 1/4 becomes 3/12, 1/6 becomes 2/12. We only now add the numerators, 3 and 2, and we get 5 rooms for every 12 hours. But the question is about 1 room. So how long does it take for them to paint 1 room? So we use this conversion factor that we just created, and we have to flip it because we want to see the rooms cancel out. Now we will get an answer left in time, which is simply hours. And the answer is 2.4 hours. And here is your 8.2 practice questions.